dear students, welcome to Easy BTech, your guide for BTech and beyond. We are discussing about subject signals and systems, and today's topic is jet transform. Very important topic. And before going to our topic, all of you subscribe, share the channel. Let's start our session, jet transform. So today's session, jet transform. So first we discuss jet transform definition, okay, and then we discuss problems of given signals, jet transform. So first, what is jet transform? What is jet transform? What is the meaning of jet transform? So actually, this jet transform is used for, what is the use of this? I am telling that this jet transform is used for analysis of discrete time signals and systems. This jet transform is used for studying or analysis of discrete time signals and systems. Discrete time systems. Only for discrete time signals and systems. Okay, that is the first point. And using this jet transform, you can find using jet transform we can find impulse response. We can do impulse response and system function of discrete time LTI systems. So for discrete time LTI systems, we can do impulse response, and we can also do system function, discrete time LTI system, linear time invariant systems. Okay, and the next thing, so these LTI systems are described by discrete time LTI system. Discrete time LTI systems are described by difference equations. Discrete time LTI systems are described by difference equations. Right? So using jet transform, we can convert the difference equations as using jet transform. We can convert difference equations into simple algebraic equations. Difference equations into simple algebraic equations. So these are the points we have about jet transform for analysis of discrete time signals and systems, and we can do impulse response, we can do system function, LTI system regarding, and we can also convert difference equations as simple algebraic equations. So these are the points. Let's see now the definition of jet transform of a discrete time signal. Definition: jet transform of a discrete time signal x of n. Jet transform of a discrete time signal. What type of signal? Discrete time signal x of n is defined as so this is a way of representing Z transform. Z transform of x of n is equal to capital X of Z is equal to summation n is equal to minus infinite plus infinite x of n into Z power minus n. So this is the Z transform formula or Z transform definition. Whose Z transform this is? A discrete time signal x of n, right? Now here Z is a complex variable. Z is complex variable which contains real part and imaginary part. Complex variable. So in polar form we can write Z is equal to r into e power j omega. So this is a complex variable in polar form. We can write Z is equal to r into e power j omega. Here r indicates magnitude of Z, and omega indicates phase of Z or angle of Z. This is magnitude of Z, r is the magnitude, and omega is the phase. Right, now I'm going to substitute this r into e power j omega in the Z transform formula. Then we get summation n is equal to minus infinite plus infinite x of n into r power or r into e power j omega. First we write r into e power j omega power minus n. So in the place of z, just we are substituting r into e power j omega power minus n. This summation we can write as summation n is equal to minus infinite plus infinite x of n into r power minus n e to the power minus j omega n. Right? So here the signal x of n is multiplied by r power minus n. X of n is multiplied by exponential function or exponential sequence or exponential signal r power minus n. This is the exponential signal r power minus n, first point. And the second thing is, I am writing again summation. The summation n is equal to minus infinite plus infinite x of n into r power minus n. I am keeping bracket into e power minus j omega n. So this summation is also indicates discrete time Fourier transform of this summation. Total formula indicates discrete time Fourier transform of x of n into r power minus n. So this is the meaning of this total summation. Okay, x of n into r power minus n, Fourier transform. In the next step, what I am doing, so here r is the magnitude of z. I am taking 1. Then the summation will become n is equal to minus infinite plus infinite x of n. Here r is a 1, so I am not writing 1, e power minus j omega n. So this total indicates capital X of e power j omega, which is equal to DTFT, discrete time Fourier transform of x of n. Discrete time Fourier transform of x of n. Right? So take this as 1. Just R value we have taken as 1. Magnitude of Z is 1. Now, as per Z transform formula, as per Z transform of x of n is equal to x of z is equal to, what is the formula Z transform? N is equal to minus infinite plus infinite x of n z power minus n. For example, take it as 2. So by comparing 1 and 2, we can say a relation between Fourier transform and Z transform. So we have relation, or we can say relation Fourier transform and Z transform. So what is the relation? Z transform is equal to, that means x of z is equal to, the meaning x of z is equal to dtft of x of n by keeping z is equal to e power j omega. Right or not? By comparing 1 and 2, you can tell in the formula x of n summation minus infinite plus infinite, here also minus infinite plus infinite, x of n, here e power minus j omega n, here z power minus n. So DTFT and Z transform both are becoming same. They both are same. So left side I am taking DTFT and right side I am taking Z transform. They both are equal if substitute Z is equal to e power j omega in x of z. This is the relation between DTFT and Z transform. So important point, this is called relation between Z transform and DTFT, discrete time Fourier transform. Right? So here Z transform and DTFT formula both are compared, and the relation is Z is e power j omega. So DTFT will become Z transform if you substitute Z is e power j omega. Next thing, I am going to take Z plane. What is Z plane? What is the meaning of Z plane? So as we know that Z is a complex variable, we can write as r into e power j omega, right, which is a complex variable. That means it contains real part and imaginary part. It contains real part and imaginary part. So here omega is the phase. Omega is the phase. So it can be changed from 0 to 2 pi. The phase of Z can be changed from 0 to 2 pi radians. So now if you change the omega 0 to 2 pi, right, first I will draw a Z plane, then we go for changing of omega 0 to 2 pi phase. So let's have Z plane, x axis here, y axis. So what is the Z here? Z is a complex variable which contains real parts. So here x axis is the real part of Z, or real axis, and y axis is the imaginary part of Z, or imaginary axis. Now here omega is the phase, it will change from 0 to 2 pi. If you change the phase 0 to pi, we get a circle in the Z plane. So circle is obtained as omega is changing from 0 to 2 pi. This circle radius is how much? R. The radius of the circle is R. Now if the magnitude of Z is R is equal to 1, then this R is 1. we get a circle in the jet plane. This circle will be called as unit circle. This circle is called as unit circle because magnitude of jet is 1. That means r is equal to 1. Okay. So in jet plane we have unit circle if magnitude of jet is equal to 1, right? So this is the jet plane, right? Next thing, so we are going to do problems, right? So now the first problem, find jet transform of a power n u of n. So this is the signal he given. He wants jet transform of a power n u of n. So we can do easily. The solution is, so a power n u of n is called exponential sequence. The name of this signal is exponential sequence. Real exponential sequence. So we know that jet transform of a signal x of n is equal to x of jet is equal to summation n is equal to minus infinite plus infinite x of n jet power minus n, right? So here the given signal is a power n u of n, so I am going to substitute in the place of x of n summation minus infinite plus infinite a power n u of n jet power minus n. So here u of n is a unit step sequence. The meaning of u of n is unit step sequence, which is equal to 1 for n is greater than or equal to 0. For n less than 0, u of n is 0. Therefore, because of this unit step sequence, the limits of summation will be 0 to infinity. Because n greater than or equal to 0, this unit step sequence is 1. Therefore, a power n 0 to infinity is the limits. No need to write minus infinite plus infinite. Now limits are 0 to infinite, a power n, and u of n value is 1 jet power minus n. So now I am writing this as summation n is equal to 0 to infinite. I am writing something power n, like something power n. So for every problem in jet transform, this is the logic. Summation n is 0 to infinite, something power n we have to write. So here in the bracket what we get, a jet power minus 1 or a jet inverse power n, right or not? Both are same. So we have a series formula, infinite series formula. What is that is, if we have summation 0 to infinite, n is 0 to infinite, like c power n, this value, this summation is 1 by 1 minus c if c value is less than 1, right? If c value is less than 1. So this is the condition. The c value must be less than 1. Mod c is less than 1. Then only the c power n total will become 1 by 1 minus c. So here also same condition we are going to take because it is like c power n. So this total will become 1 by 1 minus a z inverse. When this is possible, if mod c is less than 1. So here mod a z inverse is less than 1. So this condition is called ROC, region of convergence. So this condition is called region of convergence or converges. So mod c is less than 1 here, or magnitude of c is less than 1 here, magnitude of a z inverse is less than 1. In the place of c we have a z inverse, right or not, by comparison. So this is called ROC. This is called ROC. This condition is called ROC. Now we can simplify the answer. X of z is equal to 1 by 1 minus a z inverse. So here z inverse you can write as a by z, a by z, and after LCM you get Z by Z minus A. This is the result. And coming to ROC, this ROC also we can simplify. So we need to do magnitude of Z. So this will be A by Z less than 1, right? So magnitude of Z is greater than A. So this is the ROC. So we have to show ROC also. We have to plot ROC also. Plot ROC. How to plot ROC? So we need to take Z plane which contains real part and imaginary part, or real axis and imaginary axis. So take Z plane, the real axis and imaginary axis. So x-axis is real axis, real part of Z or real axis, and y-axis is imaginary part of Z or imaginary axis. So now we need to draw a circle of radius A in our problem. This we have ROC. Magnitude of Z is greater than A. So take the circle of radius A. Take the circle of radius A. So I am drawing the circle. Radius is A. The radius of the circle is A. Now what is ROC here? Greater than A. Outside the circle. Right or not? So outside the circle we have to draw strips or lines. Excuse me. So here ROC is magnitude of Z is greater than A. That means outside the circle A, radius A. So take the lines outside the circle. Okay. So this is a ROC. Right? So here I am writing ROC is mod Z greater than A. So here the given signal is a right-sided signal, right or not? Here the point is right-sided signal and infinite duration up to, it is U of n is there. U of n is 1 for greater than or equal to 0. N is greater than or equal to 0 means 0 to infinite. So right-sided signal and infinite duration of infinite duration. Infinite duration. So for this type of signal, the ROC is outside the circle. Right or not? We got ROC outside the circle. So ROC is outside the circle. Outside the circle. That's all. So this is a one ROC property. Actually, the meaning of ROC is, the meaning or definition, range of Z for which Z transform converges. For which Z transform converges or Z transform exists. So range of Z for which Z transform converges. So statement I given, I am writing now. For which Z transform converges. So this is the problem. Very important information in this. So Z transform of A power and U of n. This A power and U of n is an exponential sequence, real exponential sequence. Its Z transform is Z by Z minus A, or we can tell 1 by 1 minus A Z inverse, and its ROC is magnitude of Z is greater than A. So here outside the circle of radius A, and this signal is a right-sided signal of infinite duration. So for right-sided signal of infinite duration, the ROC is outside the circle. Outside the circle. Let's take another problem. The transform of del of n. So this is the impulse sequence. What is the signal here? Impulse sequence. The given signal is a impulse sequence. So what is the jet transform of this impulse sequence? So first we take the formula. Jet transform of a signal x of n is equal to x of z is equal to summation n is minus infinite to plus infinite x of n z power minus n. Now the given signal is del of n. So do substitution of that. So n is minus infinite plus infinite. In the place of x of n, we given del of n z power minus n. So we have a multiplication property. Anything multiplied by del of n, any signal multiplied by del of n, the result is x of 0 into del of n. So the signal get multiplied only at n is equal to 0, because del of n means it is an impulse at n equal to 0. Therefore the signal also get multiplied only at n equal to 0. So as per that, here impulse exists at n equal to 0. This we need to keep in the next signal. That is a multiplication I am doing first. So in multiplication we get del of n z power minus 0. So this will be summation minus infinite plus infinite only del of n. Now this summation value, if you see del of n, it will exist only at n equal to 0 and its value is 1, and we are doing summation from minus infinite to plus infinite. So this summation value, how much? 1 only. The summation will become 1. And what about ROC here? ROC. Here the range of z for which z transform converges. Here z power minus 0, so z is not existing here. So ROC is entire z plane. ROC is entire z plane. Right? So this is a del of n z transform. Del of n z transform is 1. Del of n z transform is 1. Similarly, another problem we can do. Z transform of u of n. Z transform of u of n. What is u of n? U of n is a unit step sequence. What we call unit step sequence. Unit step. So what is the Z transform of this unit step sequence? And we know a unit step sequence. First we have to see what is u of n. Then we can do Z transform. So at 0 it is 1. N equal to 1 it is 1. N equal to it is 1. And so on. So this is the u of n. At minus 1 it is 0. At minus 2 it is 0. Right? This is unit step sequence. For this signal we are going to do Z transform. So how to do is, as we know the Z transform formula, Z transform of x of n is equal to x of z is equal to summation n is minus infinite to plus infinite x of n z power minus n. So here the x of n is the u of n. So I am going to substitute that u of n. Summation n is minus infinite plus infinite. In the place of x of n, that is u of n z power minus n. So here u of n, we know about u of n. U of n value is 1 for n is greater than or equal to 0. So according to u of n, the summation limits 0 to infinite and u of n is 1, therefore z power minus n. So this can be written as summation 0 to infinite z power minus 1 whole power n, like c power n. This is the logic in Z transform. Every problem we need to write 0 to infinite c power n. So 1 by 1 minus c. So here 1 by 1 minus z inverse. And what is the ROC here? ROC. C value less than 1. Here c is equal to z inverse. So z inverse is less than 1. Z inverse means 1 by z is less than 1. 1 by z is less than 1. 1 by z is less than 1 means z is greater than 1. So this is the ROC. Z is greater than 1. And 1 by 1 minus z inverse we can write as z by z minus 1. So Z transform of E of n is equal to z by z minus 1. And ROC, how much we got? Mod z or magnitude of z is greater than 1. And if you plot ROC, to plot ROC we go for z plane, real axis, x axis is real axis and y axis is imaginary axis. Y is the imaginary axis. Now we have to draw a circle of radius 1. So take the circle, radius is 1. Now mod z greater than 1 or magnitude of z is greater than 1 means outside one circle. So I am plotting ROC outside the circle. So this is the ROC. Okay students, so very easy, simple, you can do well. Just follow classes regularly. Thank you students. We meet again.